Let's say you had a balloon at a birthday party and you wanted to pop it with a pin. Do you think that every single time you try to pop it, it's always going to pop? Well, your quick answer is no, not always. It depends on a few factors, and we're going to talk about that through the collision theory. But before that, we need to ask ourselves, what is the collision theory? Well, the collision theory states that chemical reactions only succeed if the reacting particles collide with sufficient kinetic energy and proper orientation. But it is important to remember that not all collisions succeed, but those that do succeed are called effective collisions. For example, in this model, it shows whether the collisions are properly oriented or not properly oriented. So in the top example, it shows that the molecules or reactants aren't properly oriented. So despite the collision, it's not effective, it's not successful, so no products are formed. But in the bottom, it shows when the reactants are properly oriented, and when they do collide, they are able to form new products. So the reason why orientation matters is because particles must be aligned specifically for the reactive parts to make contact, enable bond breakage, and form new bonds. Now, our last factor in order to have a successful chemical reaction is kinetic energy or speed, because it's necessary to have the minimum amount of energy, also known as activation energy. For example, as we can see here in this image, a successful collision happens when there is an activated complex present, meaning that there's a minimum amount of energy. Now, the reason why the activated complex is so important to have is because during this transition stage, there is high amounts of energy and it's very unstable. However, this maximum amount of energy also means there's more heat, there's more speed, so it's going to allow for more frequent collisions to happen, increasing the odds of having a successful collision. Therefore, if you have more heat, you have more kinetic energy, and thus more activation energy, or the minimum amount of energy. So the reason why the speed of the reaction or the kinetic energy is so important is because it's directly proportional to the frequency of these effective collisions. However, another way you can increase the collision frequency is if you increase the pressure. When you increase the pressure, you're forcing the molecules closer together, which makes it have a higher concentration. So it's going to be easier for these particles to collide with each other. Last but not least, if you have a catalyst present, you can increase the rate of a chemical reaction or the speed of it by providing an alternate lower energy pathway. So what this is doing is that it's lowering or decreasing the activation energy while increasing the reaction rates.